So find the variation constant of an equation of variation where y varies inversely as x and y equals 10 and x equals 1. So we want to do two things. We want to find the variation constant, and then we want to find the equation of variation. So generically, the equation of variation is y equals k over x. If it's an inverse relation, then that's the type of equation that describes an inverse relation. Also, it can be written as xy equals k. Notice if we were to go in and multiply both sides by x to clear the fraction, we would have xy equals k. So it can be written either way. So this ordered pair, 1, 10, this is just a relation, a correspondence between an x and a y. And if we know two values in this equation, we can find the third. So k is a constant. For a given relationship and a given inverse, then k is going to be constant and x and y are going to vary. So we want to find out, well, what is k going to be in this particular relation? So we put a 10 in place of y. We put a 1 in place of x, and we solve for k. Well, since x is 1, k divided by 1 is just k, so we have k by itself. So that is k. That's our variation constant. So our equation of variation is y equals 10 over x. So we use the data point that's given in order to find our constant. And once we get our constant, then we can write our equation of variation. All right, here's another one. Y varies inversely with x. And here's a data point, an x and a y that correspond to each other. So since it's inverse, y equals k over x, or if you would rather, x times y equals k. I'm going to use this one this time. It doesn't really matter. So in place of x, I'm going to put a 1 over 8, and in place of y, I'm going to put a 32, and that is going to give us k. You may want to use this one as your general equation of variation, but if you're looking for k, notice this one has k by itself, and we said those equations are equivalent to each other. So this keeps us from having to move things from one side to the other. So we're multiplying fractions, so we need to make 32 a fraction. 8 goes into 32 4 times, so 1 times 4 over 1, so k is 4. So that one makes y equal 4 over x. That's our equation of variation. So now here we have a word problem, an application of this. And what we're given is we're given a relation between a weight and how much fat a person should eat per day if they weigh this weight. And then we want to use that piece of information to find out how much fat someone should eat if they weigh something different. So we're told that it's a direct variation, that they vary directly. So if variables vary directly, instead of k over x, it's k times x. So if it's direct, it's a product of the constant and x. If it's inverse, it's the quotient, k over x. Why is that? Well, if it's direct, if x goes up, y will go up. If x goes up, y will go up. But if it's inverse, they go in opposite directions. So let's look at an example. If this is our equation for an inverse relation, then let's pick a couple of values for x. If x is 2, we get 12. If x is 4, we get 6. If x is 8, we get 3. Notice as we're going this way, the number on bottom, which is x, is getting bigger and bigger. But the answer, which is y, is getting smaller and smaller. So for an inverse relation, as x goes up, y goes down. For a direct relation, they go in the same direction. If x gets bigger, y gets bigger. So let's use our data value. And this is the general equation for a direct relation or a direct variation. Let's use the letters in the equation. They tell us that fat, let's use F for fat, varies directly. So K times with weight. So fat has a direct variation with a person's weight. So if a person is 111 pounds, that corresponds to eating at most 74 grams of fat. So knowing two of these, we can get our constant. So F is the 74 grams. W is the 111 pounds. So if we divide both sides by 111, we can get K. So K is 74 over 111, making our equation F equals 74 over 11 times W. So now that we have our equation, if you tell me how much someone weighs, I can tell you what their fat intake should be, or their maximum fat intake. What we're looking for, how much fat intake should they have if they're 87 pounds? So their fat intake equals the constant times their weight. So if we just pull our calculator out, 74 over 111 times 87. And I typed something wrong. 74 over 111 times 87 is 58. And that's in grams of fat. So a correspondence between two values, get us having a given data point, that gets us K, and then we can determine for other values. Okay, this one is about Hooke's law. Physics behind it, but you know that if you have a spring, the heavier mass you put on the spring, or the harder you pull on the spring, the farther it stretches. So Hooke's law says that the distance d, when a spring is stretched, varies directly. So K times the object's weight. So distance, this is a direct because it's a product. So constant times the weight. So we're given the data value. 67 centimeters of stretch corresponds to 3 kilograms. So if we put 67 in for the distance and 3 in for W, we can find K. So divide by 3. So K is 67 over 3. That doesn't reduce, but let's leave it as a fraction, not a decimal. So D is 67 over 3 times W. So now they want us to find what is the distance if we change the weight. We're going to put on it. We're going to put 7 kilograms on it, and we want to find how far is this spring going to stretch. So 7 is a W, and we're looking for D. So we go into our equation, we replace W with 7, and then we can run that through our calculator. So 67 over 3 times 7 is about 156.3, or 156.3 repeating. So that's how far our spring would stretch if we put 7 kilograms on it. The last one we're going to do is still a direct variation, but sometimes the variables can be directly related linearly, meaning that both variables are to the first power, but sometimes they can be directly related to other powers. Here we're told y is directly in variation with the square of x. So not just x, but the square of x. So first comment, the square of x means x squared. This means the square root of x, not the square of x. So that's not what we're talking about. We're talking about this. So varies directly. Constant times what it's varying directly with, and that's the square of x. So they give us a data point telling us when x is 0.1, y is 0.80. So we can find our equation because all we need to know is k for our particular scenario. So we can put our y in. We can put in our x, and notice our x gets squared. So if we square x, 0.1 times 0.1 is 0.01. And if we divide both sides by 0.01, then those cancel. So k is, that's going to be 80. So our relation is that y equals k times, k is 80. 80 times x squared. So we found k. Now that we found k, plug it in, so that's our equation. On this one, they don't give us another x to find out what y goes with it. They just want us to come up with the relationship. Here's a point. We know how they're related, so we can find our constant of proportionality in order to get our equation.